Okay, for those of you who tried this, let's go over and see how you scored. If you didn't try it, you might want to close your ears or close your eyes to make sure that you don't see the answers. In this one, the limit is x goes infinity. If you factor out an x cubed, you are going to come up with, if you just divide the top two terms, you can see you get a fourth. Easy as that. Here, the antiderivative, you need to use substitution, namely that u is equal to 2x. Therefore, du is equal to 2dx. Divide by 2, you get 1/2 du. So you need a 1/2 in front of both, and the antiderivative sign is negative cosine, and the antiderivative cosine is sine. It is b. Problem 3 right here, same thing. You say that u is equal to x cubed, therefore du is equal to 3x squared dx. You have the x squared, you don't have the 3, so you need the 1/3. And the antiderivative cosine is sine, and so it is 1/3 sine of x cubed plus c. Somebody's 3 for 3. The graph of the piecewise function is shown above. If g of x is equal to this guy from -2 to x, which of the following is the greatest? Notice this is just an area collector, guys. It is an area collector. When is the area the greatest? Well, at that spot. At that point it is. After that, you get negative area, correct? Or you could think of it like this. We're looking for a maximum. A maximum occurs when f prime changes from positive to negative. This is the derivative of g, and it changes from positive to negative there. The answer is at 1. Graph of the derivative shown above. Which of the following statements is true? Here it's above the x-axis, so that means f is increasing from -2 to 0. I think that this is the toughest one for people. I'm going to make it quite simple. It says, let f be the function given by this derivative. On which of the following intervals is f decreasing? On which of the following intervals is f decreasing? So we have to say x squared minus 2 over x. We're going to look at where that is equal to 0 to see where it changes sign. Again, it's the derivative. I will multiply the top and bottom by x in order to get x cubed minus 2 over x is equal to 0. Is everybody okay with that setup right now? If you were to look at this, you know that the critical points are where the derivative does not exist, which is at 0, and then the cubed root of 2. That looks like 3 roots of 2. Let's try plugging in some values. Suppose you plug in -1. You would get a negative value over a negative value, which makes positive. So it is positive here. Plug in a value here, we'll plug in +1. And I get a negative divided by a positive, and that would be negative. And then if you plug in a value that side, say you plug in +2, you get a positive over a positive, which is positive. So the question is, which of the following intervals is it decreasing? Wherever the first derivative is negative, which means from 0 to the cubed root of 2. Letter D. Just so I could solve it equal to 0. Create a common denominator. This one, it says that these are all negative. For f of x to be negative, it means that it's below the x-axis. So which one is below the x-axis here? All 4 of these, so I know that this is not an option. What does it mean for f prime to be negative? It means it is decreasing. So I'm looking for a function that's always decreasing. Well, this one is increasing for part of the time. This one is also increasing, so those two are not options. And f double prime is negative. That means it's concave down all the time. And this is concave down all the time. This is not concave down all the time. Sometimes it's concave up, so this is not an option. This is it. Which of the following is the least value? So this is the area from 1 to 3. Yay. What happens if you do a left Riemann sum? If you do a left Riemann sum, it will be an overestimation. Overestimation. So this is not the least. A right Riemann sum will give you an underestimation. An underestimation. So not a very difficult question, but a lot of people can't interpret it very well. That's it. Particle moves along the x-axis at any time. Its velocity is given by this guy. What's the acceleration? Somebody tell me, how is acceleration compared to velocity? Yep, so just punch in your calculator, do second calculate number 6, which is your dy over dx, and simply just select 4, and you get 1.633. Ooh, function twice differentiable with f of 2 equal to 1, f prime of 2 is equal to 4, and f double prime of 2 is equal to 3. We don't even need that. It says, what's the value of the approximation of f of 1.9? Using the line tangent to the graph at f equals 2, f of x equals 2. So, line tangent to the graph, I need slope, and I need a point. The slope in this situation is 4, and the point is 2, 1. So therefore, your equation is y minus 1 is equal to 4 times x minus 2. So it says, what is the value of the approximation of f of 1.9? So this line approximates the curve. We will plug in 1.9 for x. Y minus 1 equals 4 times 1.9 minus 2. 1.9 minus 2 is negative 0.1 times 4 is negative 0.4. Add it, we get 0.6. An object traveling on a straight line has position x equals, or x of t equals at time t. The initial position is x of 0 is equal to 2. Velocity of the object is that. What is the position? Everybody needs to remember position is equal to the start plus, anybody remember? Displacement. So I take the start is at time 2, or is at 2, and I add that to the displacement. The displacement is the integral from 0 to 3 of your velocity. And you get D, 6.512. What is the average value of this? An average value of function is the integral from negative 1 to 3 of the function. The deal is then you have to divide it by the length of the interval or multiply by 1/4, as 1/4 is the length of the interval. I'm trying to do all this from memory right now because I can't find my answer key, but I can't remember what we get, so I'm going to plug it in and just see what we get. It's the length of this interval, negative 1 to 3. So I go into y equals and I type in cosine of x, and I divide that by parentheses x squared plus x plus 2. And zoom 6, let's see what we get. I better go into mode and make sure I'm working in radians. And so we'll calculate number 7. And we'll go from negative 1 to 3. And I get 0.73, and I have to divide that by 4. So 0.73 divided by 4 should be a 0.18. There we go. 13 and 12. Oh, two number 12. Silly me. These are straight from your previous test. 0 to 1 of e to the negative 4x. Find the antiderivative. You all know it's negative 1/4 e to the negative 4x. You just tested on that. When you plug in 1, you can see you get negative 1/4 e to the negative 4. When you plug in 0, what is e to the 0? It is 1 times negative 1/4 is negative 1/4. So notice you get a positive 1/4 and a minus e to the negative 4th over 4. And finally this one, what's the antiderivative sign? Negative cosine of x, evaluate at pi over 4 and 0. Everybody knows cosine of pi over 4, it's root of 2 over 2, and everybody knows the cosine of 0, don't you? It's 1, so you get negative 1. So notice you get a positive 1 and a negative root of 2 over 2. Boom! We'll pause there and see how you did. Come, our favorite section. One of the most popular questions to ask on the AP free response section is solids of revolution. Remember where you found the area between these two things? Yeah. A calculator may be required on this following problem. It says, let R be the region enclosed by the graphs f of x is e to the x, and g of x is 3 minus x squared, shown above. Can you guys tell me which one is e to the x and which one is 3 minus x squared? Which is which? Very good. So this is g of x. And so then this one is e to the x. Excellent. It says find the area of R. Do you remember how you find area between two curves? Okay. Excellent. We draw the rectangles. So we are not going to rotate it yet. We are going to do that eventually. But the first thing we have to be able to find area. We simply set up the integral. And do you remember what we do with these two functions? Top minus bottom. Does that come back to memory? And on the AP exam, you can simply write g of x is on top, f of x is on bottom. You don't have to actually write e to the x or the 3 minus the x squared. When I say essential questions, I'm saying that these are ones where if I see you get them on the AP exam, I expect everybody to get them right. And I expect that if everybody saw this on a test that I'm going to give to you, I expect everybody knows how to do this. Okay, so what am I missing? What did you say? Bounds. I don't know that bound, and I don't know that bound. Any idea how we could use our calculator to find those bounds? Exactly. These are the types of things that you'll be expected to do. So we take out our calculator, make sure you know how to do this. We plug in the following, e to the x. Most common question is, Mr. Gens, I don't know how to find e on my calculator. Well, it's second natural log right there. And then my next one would be 3 minus x squared. So I go 3 minus x squared. Those are my two functions. I'm going to zoom standard, and I need to find these points of intersection. And I'm going to do something just a little bit different here than how some people operate, but I think it's fine. I'm going to do second calculate, and I select number 5 intersection. And I'm going to go close over to the side where they intersect. It says one of the curves is e to the x, that's correct. It says one of the curves is the parabola, that's correct. I press enter on guess. I want to make sure it finds that one. And I have this spot right here. I'm going to say A is equal to negative 1.677233. So that way, anytime I reference A in the rest of this problem, it's just going to use that. So the AP exam people, they can just see A. Everybody see how I'm trying to save you time? I go to the next one, second calculate. I grab, again, number 5. I go over to the other side. I press enter and enter and enter. Make sure it grabs that one. And it says 0.83. So I'm going to say B is equal to 0.83448687, whatever. Okay? So that's B. So now I need to perform this operation on my calculator. I'm going to go into y equals, and I'm going to do top minus bottom. You could either subtract these two, or you could do what my favorite thing is to get rid of these two, enter and enter. And I go down there, and I want to press y2 minus y1. Do you remember where I grab y2 and y1? Very good. I go to vars, y vars, function, y2, minus vars, y vars, enter y1. I'm going to subtract those two pieces. So again, remember, g of x is the one on top. That's the parabola. The parabola is on top. Question, sir? Oh. Okay, cool. Thank you. So then I go second calculate, I grab number 7. It gives me this new shape here. And I want to go from negative 1.67, negative 1.67, 7233. And then I'm going to go all the way up to 0.8344, 8687. And I get 3.651 or 3.652. You can either cut it off at 3 or round it to the nearest. Those are your options. I always just cut it off at 3. The AP exam will expect your answer to be correct to the 1,000th. Are there any questions on that? Either one is okay. Now it says, find the volume when R is revolved about the horizontal line, Y is equal to 4. Oh my goodness. So we're going to take this shape right here, that we have right here, and we're going to revolve it around the line Y equals 4. So if we're going to take Blake's idea of this rectangle there, and we're going to revolve it up like this. Anybody know what shape I get if I revolve it up like that? A washer. Good. We need to be able to handle volume with things like that as well. So I'm going to draw this shape right off to the side. Who remembers the formula for the volume of a washer? Pi times big R squared minus little r squared. Do we recall that? Blake says no. Does anybody know what makes the middle of this washer? 4. I'm going to mark the bottom part here as that's where the rotation happens. Okay, I'm rotating this section. What makes this part of the washer? Three minus x squared or g of x. Good. What makes the bottom part of the washer? F of x. So what is the big radius? Close. We do top minus bottom, correct? 4 minus f of x. What is the little radius? 4 minus g of x. So therefore, if you want to find the volume, pi times the integral of big R squared, or 4 minus f of x squared, minus little r squared, or 4 minus g of x squared dx. See my nice little trick of putting A and B? That way my bounds are from A to B. See if you can plug this in correctly into your calculator. Looks like my f of x is going to be my my y1 value. and my g of x is going to be my y2 value. So I use those as I plug them in. It's going to look kind of ridiculous, but it works out just fine. Parentheses, 4 minus, and we grab our f, which is y1. And we square that. And then 4 minus y2. That's my function. I want to evaluate it from A to B. And so I grab number 7. I use my negative 1.67, 7233. And after that, I use my 0.8, 344, 8687. You can see it finds it. I get 17.109 109,341, and I have to multiply that by pi. So often in my answers I forget to multiply it by pi, and then I get a point off on my result, which I'm always sad about because I want to get a perfect score, but I've yet to get a perfect score. I'm always excited every time they release the problems. I can try them and see if I can get them right. 53.750. So you could have 53.750 or 53.751. Either way would be correct. We're not going to do the next one. I'm going to let you guys, if you want to use your calculator, that's fine, but you can actually do it without using your calculator and press pause. You can try the next I'm going to start writing some of the work down for you. Let's look at the first one together. If you set it up, and if you use your calculator, that's fine for right now. This one would be a non-calculator problem on the test. They would have you set it up as 0 to pi of sine of x minus x plus pi after you distribute the subtraction sign. The antiderivative of sine is negative cosine. The antiderivative of x is x squared over 2. And then the antiderivative of pi is pi x. If you plug in pi, the cosine of pi, anybody remember? -1, and then it's negative, so you make it +1, as you can see. Plug in the pi, you get pi squared over 2, and then plug in pi here, and you get pi squared again. If you plug in 0, the second two pieces are going to turn to 0, but anybody know the cosine of pi? Or cosine of 0, excuse me? It is going to be 1, and then you make it negative, so -1. So you can see that when you combine these two together, you get 2 minus pi squared over 2 plus pi squared. And by the way, they will allow you to leave it like that on the AP exam. So you don't have to come up with like simplest form. If you come up with something that gives you the numerical answer, they will accept that fully. Okay? You okay with that? Let us set up the next one together, and then you guys can go. It says, write but do not evaluate an integral that gives the volume of the solid generated when r is rotated about the horizontal line, y equals -pi. So we're going to rotate it around this. Anybody tell me what shape you get when you take this thing and you rotate it around this? you do get a washer. Is the thickness of the washer dx or dy? Definitely dx. What makes this line right here the center of the washer? What is that? Negative pi. Y equals negative pi. Tell me what makes this one right here. Y is equal to x minus pi. And what makes the top portion? Sine of x. Does it label them as g or f? It does. It says f is sine. So this is f of x. And this is g of x. I'm going to use that to my advantage. If it didn't, I could just write it there. So what's the big radius? F of x minus negative pi, which would be f of x plus pi. Exactly, that's your big radius. Let's look at the little radius. That would be g of x plus pi. And so I think that everybody can understand that it'll be the integral of pi times big R squared, which was f of x plus pi, minus g of x plus pi dx. And that we will integrate from 0 to pi. That would be a very typical problem to get on the AP exam. Either one of the two that we just saw. And don't be surprised if they ask you to do it by hand or if they ask you to do it by using a calculator. The last part C, is what we'll have to get to tomorrow along with some other pieces. But volume and area, super crucial.